then it will find it. And you can easily just copy everything. So don't spread things out. Keep everything you need inside this directory. Everything. If it's spread out, copying will not work. Okay? So, let us now see what we can do with this. We go back to QGIS, and now I simply select New Project. So just Project and New. And it becomes blank. So up here, let me increase this maybe to 300%. So up here, I simply selected Project and New. And I got a blank project. So, now let's check the important settings in here. We go down to Properties, which we have here. I will also show here, so that you see clearly. So down to Properties, click here. And then we have this huge properties list of the project. What is important here? I want to point out a few things that are especially important. First, you go to General. Here. And here is one small setting that is super important. Save paths relative. That's what it says. Here. So save paths relative. What does it mean? It means it doesn't store the projects and the layer locations as C, Rockberry, blah blah blah. It just goes from the project file and downwards. And this setting, relative, means that we can copy it. If we would set this to absolute, it will only work on our computer. So just check that save paths is relative, because then it will be relative to the project file. Other selections here, not that much of importance. So we go down to CRS, Coordinate Reference Systems. And here we will see that, well, simply the number of coordinate systems is simply enormous. And you will see that every coordinate system has a number, which we can see here. And this is called the EPSG number. And that's simply a unique number for every coordinate system in the world. Then, just as a curiosity, you might wonder, where did they come from, these numbers? What is EPSG? Is it some kind of surveying, international surveying organization? No, it's much more commercial than that. It was simply the oil companies in Europe that had a lot of different oil fields in different places with coordinates and different coordinate systems. And they wanted to make an accurate list so that they could get all oil fields into the same coordinate system. And, well, they deal with oil, so they had a lot of money. So they went into checking almost every coordinate system in the world. So EP stands for European Petroleum. But it has to do with coordinate systems. So, just a curiosity. Anyway, what do we do here? We select the coordinate system that we will use. And it's just here very important to be consistent, which means you use the same coordinate system throughout. If in the future there will be a decision that, no, we don't want that. Okay, you can always transform. You will you will not lose the accuracy. You can do an exact transformation. But until then, we will simply use one system, which is called the WGS84 UTM Zone 28N. Why is this? Well, simply, the WGS84 is the coordinate system connected to the GPS system. So it means that if you, let's say that you use, well, just a mobile phone, you check the coordinates and so on, they will use this system, the WGS84. And it says not to go too much into details, it says where do you define the equator, the North Pole, and the size of the Earth. And to just keep this short, they are different between different countries. So for example, if we see this Sierra Leone 1968 coordinate system, it uses another definition of the equator, another definition of the North Pole and the size of the Earth, which moves the point, not a meter, but what did we check? 120 meters, I think. So if you switch coordinate system between these two, you will have errors of up to 120 meters. And that's simply how you define the equator. So the difference of defining the equator is moved 120 meters. And then you might think, with all technology, can't you decide where the center of the Earth is better than that? Well, it hasn't. It's not connected to that at all. Each country wants the Earth to perfectly touch an ellipse. And to do that, you simply move the equator. You don't care about the equator. You want the perfect coordinate system for your country. And this one, Sierra Leone 1968, fit perfectly to Sierra Leone. This one, no, not as much. But this is the international one. So that's why we have different systems. But here, to be consistent and to keep it easy to use different equipments and avoid the problems of having different coordinate systems, we stick to this one, WDS 84, UTM, Universal Transversal Mercator, simply a system with 60 different zones all around Earth. We have zone number 28 and we are north of the equator. So this one is important. So, and again, why this? Well, the problem between these two is mainly the height, that the height becomes very strange when you measure with DNSs, for example. We don't care about the heights. We have only horizontal coordinates in our project. So, because of that, we stick to this system, because then we can use any device and we'll get the position anyway. This is a bit more tricky to set. So, just keep this. How do we find it? Simply go to filter, and we can just type 28N. And then search. And then we will see in our long list that we have not so many systems to choose from. Then we will find here in the list selected all that has 28N. We can easily find our system. It would be a little down here. Yeah, here. So there are thousands of them, but use the filter. Just type 28N and you will quickly find, oh, there it is. So avoid Sierra Leone 68, otherwise we will have a confusion. If in the future there is a decision from the authorities that, no, we should have this instead, no problem, we can transform. But then we do that consequently with everything. So until then we stick with this. Okay, so I use that. And then the system is selected. Okay, so I just push OK. So now I have selected the system. Also at this stage, give a name, save the file. So then we just choose project, save as. And here, go to your project. So in this case I go to Rodberry delineation data, and I call this Rodberry editing. Here we maybe have some kind of structure. We will have many files, so we maybe put the date. So today is the 12th of July 2025, something like that. But we will see later if we find another name. But just be consequent with the names also, because it's super important that you have just the same structure. Otherwise, if you switch files, and you have different ways of naming them, or not naming them at all. I mean, the no name 21 was, oh, yeah, here it's all the data. Oh, that's horrible. So just be very careful with the naming and where you put the files. So, okay, I save it in the right place here. So let us see again. So any question regarding this? These were the settings, the main settings, and how we structure the projects with the project with the files.
As I have a question.
Yes.
What if your drive is division? like you have drive C and drive D. If you like your drive, your computer drive, it may be divided, like you have drive C and drive D.
It doesn't matter.
Yeah, so if I save it on drive D, is that a problem?
No, since we set paths relative, which
Okay.
means that it will not look at the drive. It would just look at from the project file and downwards in the structure. So set path relative, we avoid that problem.
And also, if I want to make a backup, then I slot my USB, just like that
Yeah,
USB right
so
there.
just take the whole directory, Rodbury delineation data, and you have everything.
Save it in the USB. It's okay.
Yes, yes.
Okay.
So that's also the convenient thing. Store everything in one directory. The backup becomes a 5-second thing. Just click, copy, then go and have a coffee.
Yeah.
Okay, so we just give a name, proper name here. Rodbury editing. Yeah, looks fine. It takes the name from the direct from here. So let me just go back here, and then I push save. So all the way up here, I will now see the name Rodbury editing. So fine. Okay, so let's import some data to the project. This is done by clicking on this icon. I will zoom in so that you see it. Up here, this one. Open data source. Manager. So I click it, and up comes this. Here we have to select which type of data do we have. And we have two categories that we will work with. The raster is simply all types of images. The vector is points, lines, and areas, which is our delineation data. So now I want to import, in this case, first maybe the background file, the raster file. Okay. So I click here, raster. I go to raster datasets, click here. And I simply then go to, in the project, to imagery cutouts. And here I will see that I have this Rodbury 50 centimeter image referenced, JPEG. Important also, here you can see two more files. One is called JGW, and the other one is called JPEG AUX XML. The JPEG is just a compressed picture. It has no information about the coordinate system. Nothing. So it's just a picture of the area. These two are files that contain the coordinate system. So they have the same name, but different extensions. Why are there two? Well, QGIS and also Qfield works perfectly with both. So normally I only use the JPEG AUX XML file. It's more advanced, you can see, you have many settings. And that also will be automatically generated by QGIS if you import and dereference a file. This one will be used. However, if you use the Field Genius software, it only accepts an old version of the transformation of the coordinate system, which is called a world file, JGW. So JG stands for JPEG and W stands for world. So this is an old system. So it has to be created specially if you want to use it for Field Genius as a background image. You need this, otherwise it will not find the file. So this one works with Qfield and QGIS. This one works with the Field Genius. And it just contains the coordinate system of this file, which is simply just a picture. Okay? So we select to open the JPEG file. Don't click on one of these, then it will say error, because then it will assume that this is a picture. It is not, it's just a coordinate system. So click on the JPEG file, and then we go down to add. And then we push close. And then we will see something that you will say, oh, not Rodbury again. You have been seeing it every day. But here it is. So say hello to Rodbury. Okay, so now we have the image. It will show that each image is